Let's dive deep into one of the most crucial processes in modern manufacturing, and that's injection molding. We're going to explore that many type of plastics forming techniques that exist today. If you ever used a plastic product, let's be real, we all have, doing it right now, it was probably made using one of these methods. But what's the difference between them, and why does it matter for development? So, what exactly is injection molding? Injection molding is a manufacturing process used to produce parts by injection molding material and making the mold. Most commonly, this material is thermoplastic, but thermosetting plastics and elastomers can also be used. The process starts with the plastic pellets that are heated until they melt. This molten plastic is then forced into a steel or aluminum mold cavity under high pressure. Once cooled and solidified, the part is ejected and ready for the next step, be it assembly, finishing, or shipping. What makes injection molding so powerful? It's scalability. It's ideal for producing high volume of identical parts with incredible precision and repeatability. Think toothbrushes, phone cases, or automotive panels, or even Lego blocks, all made using injection molding. But injection molding isn't one size fits all. There are several types of injection molding, each suited for a specific application. Standard conventional injection molding, this is the most common type. It's used for a mass production of a simple, moderate, complex plastic parts. Consumer goods like plastic cutlery, bottle caps, and even TV remotes. Housings are often made this way. The molds used here are typically steel and very durable, capable of producing millions of cycles. Real-life examples, basically every time you open a shampoo bottle, that cap likely came from conventional injection mold. Number 2, overmolding. Overmolding is a bit more complex. It involves injection plastic over another material, usually another plastic, rubber, or even a metal. This is used to add grip, create multi-material designs, and encapsulate electronics. Think about your toothbrush handle with a soft rubbery grip over a hard plastic core that's overmolded. It's common in tools, electronics, and medical devices where comfort and functionality meet. That's an important part. And now we have insert molding. Insert molding is similar to overmolding, but typically involves placing a preformed or preformed insert, like a threaded metal nut or circuit board, PCB, into the mold before injection molding process, basically before injecting the plastic around it. The result is a strong bond between the insert and the mold plastic. Examples include knobs with the metal threads, some surgical instruments, and connectors. Next one, we have a micro-injection molding. This technique is used to produce extremely small, high-precision parts. The mold cavities and shots are measured in milligrams. It's common in the medical and electronic industries, where components like microfluidic devices or miniature sensors are required. It demands tight tolerances, advanced tooling, and very, 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 very sophisticated machinery. Next one, we have a gas-assisted injection molding. In this process, pressure gas, usually nitrogen, is injected after the plastic, creating a hollow section within the part. This reduces the weight, material cost, and cycle time, as well as eliminates sink marks on the thick parts. It's used in the production handles, enclosures, and part in automotive and furniture applications, such as chair armrest or dashboard components. Next one, we have a thin wall injection molding. This is used to create parts with very thin walls relative to their size, maximizing material savings and improving cycle time. Common in the packaging industry is basically how many disposable food containers and drink lids are produced. High-speed injection machines and special molds are needed for this type of molding. The next one, on number 7, this is two-shot or dual-shot molding. Two-shot molding injects two different plastic in one cycle, creating a single part with the multiple materials and colors. This is very often used in toothbrushes again, automotive switches, or consumer products that require both aesthetics and functionality. like a soft touch on a rigid body. The next one, number 8, is structural foam molding. This uses a blowing agent mixed with a plastic resin to create a foam-like structure. The result is a part that's lighter and often stronger due to cellular core. Structural foam molding is popular in industrial equipment, cases, and large thick wall products that don't need perfect surface finishes. Number 9 is something that we call reaction injection molding group, RIM. Unlike thermoplastic injection molding, this one uses a chemical reaction between two liquid polymers to form a solid part. So now it's a liquid. Inside the mold, it's used for a large, lightweight, and impact parts such as automotive bumpers, instrument panels, and the medical housing. Through technically not thermoplastic injection molding, it's part of the broader family of molded plastic techniques. Beyond injection molding, other plastic forming techniques, while injection molding dominates mass production, some other methods are also essential, especially for specific shapes, function, or production volumes. The next one we have is blow molding. Think about bottles and hollow containers. A tube of plastic is inflated inside the mold, taking its shape. It's super ideal for high volume packaging. This one is also very, I would say, famous and popular. It's used quite often. We use it as well. Rotational molding. It's used for a large hollow parts like a big storage tanks or even the playground equipment. A mold is slowly rotated while heated, evenly distributing the plastic. As well, one more that we are very commonly using it, thermoforming. Sheets of plastics are heated and vacuum formed over a mold. This is common for disposable trays, lids, and blister packagings. The next one, compression molding. It's very often used for a thermosetting plastic or rubber, where the material is placed in a heated mold and compressed into a shape. It's very common in electrical housing, automotive parts, and even appliance panels. Each process has trade-offs in tooling cost, lead time, part complexity, and material choice. Injection molding varies for precision, repeatability, and scalability, but only if your volume justifies the upfront tooling investment. At X-PRO, we help clients navigate these options every day. Whether you're launching a consumer product or developing custom component for a specialized industry, we guide you to the right method for your product, your budget, and your timeline. Understanding these techniques and technologies is a key to making a smart decision as you turn your ideas into manufacturing reality and manufacture product. Let us know if you're considering injection molding or any technique, as we can help you from the beginning and make sure your product is designed in a certain way for a specific technology. We are here to help, so make your product vision real.